System 390 Technical Insights, how the VM-ESA system saved the University of New Mexico space, time, and money. Plus, how the partnership between IBM and SAIC has created an imaging application called Mosaic. All this and more next.
IBM presents System 390 Technical Insights featuring VM-ESA with your host, Joyce Tomaselli.
Welcome to the second edition of System 390 VM-ESA Technical Insights. Today we're going to discuss three key aspects of VM-ESA. First, applications, specifically a new image application called Mosaic. Next, performance. We'll talk about some VM-ESA capabilities you can use to ensure good system and end-user performance. And finally, cost of computing. What is available with VM-ESA to help you reduce your costs today, and what IBM intends to do to keep your costs going down. We have three people we're going to discuss these things with today. First, we have Dave Hemseth. Dave is a senior programmer responsible for Mosaic technical and marketing support for IBM. We have Charles Lickel. Charles is the VM product owner and system manager. And we also have Doug Morrison. Doug is an IBM senior programmer with VM's performance and system evaluation department. Dave, you were involved with producing an image solution for VM. Can you give us some background?
Yes, a few years ago I was on assignment in the IBM headquarters group with responsibility for all of our operational image solutions. That includes products like Image Plus on MVS and AS400. So initially we had spent some time, about 3 months, meeting with customers around the country, customers who were primarily running their main line of business applications on VM or VSE guest systems on VM. Mm-hmm. Once we'd established that they had a requirement for image similar to the other platforms that IBM already had in progress, we then proceeded to go about finding out how to solve that need to provide an imaging solution on VM.
Can you give us some specific applications that people were looking for solutions for?
Yes, applications such as insurance claims processing. There are many small to medium-sized insurance companies that run one or more VSE guest images on VM rather than MVS. Office automation is a large area of use for imaging, material safety data sheets, land records, deeds and such, and so many different types of applications since VM is very much a cross-industry type of environment.
Okay. Did you look at several different solutions?
Yes, we tried to identify resources and work in process within IBM and with business partners as well. And we looked at several different solutions before identifying Mosaic from Science Applications International Corporation, SAIC in San Diego.
Why did IBM choose SAIC's offering?
Well, at the time we met SAIC, they were in the process of already porting an existing imaging solution, the predecessor to Mosaic, from a PC-DOS LAN server environment to the VM server. The function that was already present in the product met very well with the requirements we had been gathering directly from customers and our industry research. And it also fit very well into the new evolving role of VM as a server in a client-server solution environment.
Recently, we talked with Dan Hunziker. He's the chief architect for Mosaic at SAIC. Let's listen to what he has to say about the product.
Mosaic is a client-server architected system where the server portion of the product runs native in the VM environment. The client portion of the product is a graphical user interface controlled by Microsoft Windows on PS2s, connected via either Ethernet or token ring LANs. Mosaic is a true document imaging system. Paper documents can be scanned into the system. They can be stored on optical storage or optional DASD. They can be indexed using the power of a relational database, SQLDS, the product on VM. So it can be used as an archival of paper documents. It can also be used as a workflow productivity tool for routing what normally would be paper documents throughout an organization. The retrieval time in the system to get a piece of information back out of the system can occur within a matter of a few seconds. There are several advantages of moving from the older versions of VM up to the newer versions of VM and ESA. Our product actually started off on VM SP6. we require the SIPC for communications to the workstations and other components of the system. In moving to ESA, we have found a marked improvement in the reliability of the overall system. And in addition, since we're using the SQLDS database as the index manager, with the newer versions of that product, we will be able to exploit the data spaces available in the ESA architectures. We support an application programming interface within the Microsoft Windows environment for integration into those kinds of applications. We support an API available from the VM CMS environment for integration into existing VM applications as well as off-the-shelf VM products. The primary example of that probably is in the Department of Natural Resources in Florida, to be able to, using this new scripting facility, integrate image services to an existing 3270 application without modifying the application. At the Florida Department of Natural Resources, they were in a situation where they had an Ethernet and a token ring segment, and they needed to have workstations to be able to access the same repository of information at either location. And so they set up a number of workstations in either one of those environments that have access to the same database and image information. The end user interface of Mosaic is geared towards a clerical end user who may not be so concerned about the technical problems in developing such a system. The primary user interface for the end user is a desktop model where there are separate icons on the desktop that represent the various functions within the system. For example, there is an icon that represents the scan function. For a user to enter a new document into the system, they simply double-click on the scan icon. Up pops a window of the scanner application. They have complete control over the digitization process within that application. The major software pieces of the system for the workstation are DOS and Microsoft Windows. The communication product that we're using for the connectivity between the workstation and the server is something called PWSCS. On the VM side, it can be either VM-ESP6, VM-ESA 1.0, or VM-ESA 1.1. The database manager is SQLDS.
There are several different image products available from IBM and its business partners on other product platforms. Can you compare Mosaic with a few of them?
Yes, before I start that though, one of the things we try to do when we partner with SAIC is to make sure that the Mosaic solution will be complementary to the other IBM products, complementary in terms of addressing the needs of customers on VM and VM-ESA, and also to have interoperability capabilities with those other products like Image Plus. So if you start at a level of what the basic functions of an operational image solution are, they're all quite similar no matter what the platform. You have to be able to capture images, either like facsimile transmissions or just scanning paper. You need to be able to store that in an economical way using a combination of magnetic and optical storage. You need to be able to index it, be able to retrieve it later, be able to share it concurrently so you don't have to wait while one person is looking at the electronic images, be able to have print capability, outbound fax capability, and other additional things as time goes on, such as workflow, automatically routing the work that's based on the electronic equivalent of the paper. So Mosaic, as well as IBM's other imaging solutions, has all these capabilities. It also has the ability to integrate with the line of business applications the customer has, whether they are VM applications, say, such as Office Vision, or insurance claims processing on KICS VSE guest machine.
Okay.
The requirements are essentially the same. The main difference is where does the customer run their key or critical line of business applications. And in the case of Mosaic, they are running them on VM or a VSE guest machine.
Okay, good. Dan Hunziker at SAIC mentioned a product called PWSCS. Can you explain what that is and why it's important to Mosaic?
Okay, PWSCS is an acronym standing for the product named Programmable Workstation Communication Services. It provides a method of workstations to communicate with each other and a VM-based host server in a very cost-effective manner, in a way that's very much optimized for the workstation to VM environment. PWSCS was absolutely crucial to the success of the development of Mosaic because it provided us a very low overhead, high-performing method of the workstations being able to store and retrieve images to the host. The actual electronic images are very large in comparison to the normal coded data text. For instance, even after they're compressed at a ratio of more than 10 to 1, the average image size is over 50,000 characters. So PWSCS provided us exactly what we needed, what Mosaic needed to be able to move these images from the host server to the workstations and back in a cost-effective and efficient manner.
Thank you. Doug, Dave just gave us some specific performance examples with Mosaic. If we focus more generally on VM-ESA as a system, tell me, would VMSP or HPO customers see a benefit, a performance benefit, when they go to VM-ESA?
Yes, they would, because VM-ESA was designed to perform well on ES9000 processors. It exploits the architectural advantages of the ES System 390 hardware to provide performance improvements and greater capacity to both applications and end users. Some of the advantages of ESA is that it removes some of the System 370 architectural constraints, such as limited real and virtual storage sizes. There are also specific line items within VM-ESA that address performance that will increase system capacity, reduce end-user response times, and improve the efficiency of the IS organization.
Can you discuss some of those specific functions?
Well, there's a lot of them. There's probably about 20, but let me just mention about 5 that are kind of some of the key ones. Specifically, VM-ESA provides performance improvements through larger real and virtual storage sizes. This not only improves performance by eliminating real storage constraints and reducing paging, but it improves the efficiency of the system programmers and application writers by eliminating their need to be concerned about managing real and virtual storage limitations and sizes. Another one is VM data spaces support. This is a major performance improvement to applications that share data. Such applications are the shared file system, SQLDS, Fortran, and a lot of third-party products share data. VM data spaces provides high-speed transfer and access of data between several virtual machines. VM-ESA also provides support for newer and faster I/O devices, such as 3390 DASD, 3990 DASD control units, and the 3490 tape subsystems. In combination with a new version of VTAM, VM-ESA provides improved SNA network performance by reducing constraint relief and storage, reducing the number of VTAM images that are required, and by a new polling function within VTAM. Also included in VM-ESA is support for SCON, which provides fiber optic data transmission technology to the end user. And there are a lot of new self-tuning parameters in the VM-ESA that will allow the system to react to changing workload within the system automatically, and thereby reduce the amount of intervention required by your system programmers to keep the system tuned.
When customers migrate to VM-ESA, what are some key areas that they should focus on to ensure good performance?
Applications that are used by many users should put their application in a shared segment. This prevents many duplicate copies from residing in storage and causing contention and additional paging. Also, in the area of shared segments, when migrating from an older release to a newer release, the customer should be very careful to ensure that the new release is using the shared segment. Some of the problems we've seen in the past is what we call shared segment dropout, and that they think that shared segments are being used when in fact they aren't. If they see a large increase in the amount of paging when going to a new release, they should investigate the shared segment area first. In the area of dedicated page volumes, VMSP and HPO allocated paging data sets wherever they found DASD space available. In VM-ESA, we have a new paging mechanism called block paging, and it performs best if the paging data sets are placed on a dedicated DASD volume and not shared with other things such as the spool, mini disks, and databases. For mini disk caching works best if you use it with expanded storage. This will allow VM-ESA to actually outperform VMSP and HPO for CMS-intensive environments. In the area of trace tables, you can reduce the size of the trace table. The default sizes that come with a system result in very large trace tables being generated. In fact, on a 6-way processor, up to 64 megabytes of real storage can be reserved for the trace table. So the size of your trace table can be can be reduced, and it's highly dependent upon what your application is or what your individual storage requirements are. So you need to consult the init and tuning manuals to find out what size you can reduce it to. In the area of IOCP data sets, in working with a lot of large customers that have many guest operating systems like VSE and have online databases like CICS, we've noticed that if they have incorrect IOCP data sets, that it will cause increased overhead in the VM-ESA supervisor. Now, where the problem resides is in the way control unit parameters are defined. In one particular customer, after we corrected his control unit parameters in the IOCP, we reduced his CPU overhead by 33%. Most of the problems occur in the way terminals and DASD control units are defined in the IOCP. And what your system programmer should do is make sure he understands how the control units are being used at his installation and refer to the IOCP user's guide to ensure that they're properly coded.
You mentioned the shared file system. Can you tell us some more about that?
Sure. Shared file system was new in VMSP Release 6. And VM-ESA provided added function and capability to the shared file system. These include hierarchical directories, file level sharing, rollback processing, and file sharing across multiple systems. We've made numerous performance improvements in the shared file system in VM-ESA. And in combination with exploiting data spaces, the performance of the shared file system in VM-ESA is comparable to the mini-disk file system.
The shared file system is very important to many of our VM customers. One example is the University of New Mexico, which is using the shared file system and many other VM-ESA capabilities for both its administration and its students. Nestled in the tranquil Sandia mountain range is the University of New Mexico, whose students and faculty share a peaceful coexistence using VM-ESA.
We use VM-ESA to provide the services that we want to the university community, in that we can run both an MVSXA production and a test environment without interfering with either one. And at the same time, the students can use the CMS environment for their needs. The computing environment consists of IBM 9121 that runs VM-ESA, and also CMS and MVSXA are running under VM-ESA. We also have a 9370 and also a variety of other machines that serve the administrative and academic needs of the university.
Here at UNM, we're serving two groups of people. We've got the administrative staff. They need a high availability, reliable system that they can get their work done on. They need consistency in their systems. We also have the academic community, the students working on their classwork and working on other non-class related computing needs, faculty, researchers. All of them have needs that are distinctly different. They need fast response, they need a wide variety of computing platforms. We've traditionally run several VM computing platforms, one for the administrators and one for the students. ESA has given us the opportunity to put all of our efforts into one platform that will meet all of the needs of the university computing community. At UNM, our desire is not to stay current so much to be on the leading edge. We're not concerned at UNM with being on the leading edge of technology. What we do need, however, is to stay very close to the leading edge of capabilities. We need new functions available very quickly. It's not uncommon for people in our user community to come to us immediately after a concept has been announced and ask for us to implement it. We can do that as long as we aren't held back by the current level of our system. If we have the opportunity, because we're on ESA 1.1, to exploit a new platform, that's a very good thing for us. Probably the most important function, or the most important feature of VM-ESA for our users is the shared file system. Our users are used to a hierarchical file structure, they're used to directories and files, and they're very comfortable with that method of organizing their work and their data. The university has several terabytes of data already stored. managing that much data becomes a real headache. It can take a great amount of time, and it can cost a great deal of money to store that much information. With system-managed storage on VM-ESA, we not only have the ability to drive our data administration via policies, we also have the ability to automate it to a great degree so that less of our programmer time is spent in managing a user's data and more time can be spent really assisting the user. By using RTM to monitor performance and using the interactive dynamic commands that are available for tuning VM-ESA, we're able to tune, watch the results, and continue the tuning process during the day without interrupting anyone's work. The university has been maintaining 2 VM platforms for some time in order to serve the diverse needs of academic and administrative computing. What IBM has done for us with ESA is give us a platform that is compatible with both those sets of needs. We no longer will have to have 2 separate machines or even 2 separate versions of the operating system or even 2 separate versions of CMS under the operating system in order to give the full suite of services with high effectiveness, with high efficiency, with good management. Over the past 2 years, we've added 2,000 new users to VM systems. Over the next few years, we may add another 2,000 new users. The only way we can do that is if we can store their data effectively, manage them effectively, and if we can do it all on one platform. That platform will be VM-ESA.
VM-ESA has been extremely reliable and has allowed the system programmers to perform their duties well with minimal resources and cost to the university.
The University of New Mexico talked a lot about capability and performance, but they especially talked about cost effectiveness. Every company in the United States has felt the current economic crunch, from the largest corporation to the smallest mom-and-pop grocery store. Charles, what are we doing to help our customers keep the cost of VM as low as possible?
Joyce, every customer I talk to reiterates that point, that we have to keep the cost of computing as effective as possible and continue to improve it for the 9 million users that use VM every day. As with New Mexico, we've continued to focus on improving the storage management capabilities and the systems management capabilities of that storage. But in addition, we focused on just about every other aspect of VM. But let's look at a more detailed example of the type of savings you can get delivered through your ESA product. With the chart that we're now showing, you can see that in the past, a outage of 1 hour could cost a customer as much as $30,000. With the type of savings we're seeing with ESA 1.1, it reduces that down to $4,500, more than $25,000 savings.
And that's because VM is more reliable?
That's because VM is more reliable and more focused on reducing not just the unplanned outages, failures of the system, but more importantly, reducing the planned outages and getting that number down significantly. In Release 2, we've maintained that focus, and in the experiences we've seen so far in the early support of the product, we're seeing savings up to 97% over the previous base of XA.
Excellent. You are the VM product owner. It's your baby. What is your strategy to ensure that VM continues to enjoy more and more success?
You're right, VM is my baby. And as VM grows and matures, I want to ensure that it continues to be as successful and as popular as it's been in the past. And the key area that customers tell me that we have to put our focus on, and an area that VM has provided leadership in the past, is open systems. And ensure that we move aggressively into the new platforms that are being defined as open. And those include such things as Distributed Compute Environment, DCE, such things as POSIX. Through these new mechanisms and through these new open interfaces, customers will be able to move more applications more easily onto their VM platform and deliver more function to their customers within their enterprises.
We've seen some real positive feedback from our key customers and business partners on VM. What are our IBM executives saying about VM?
Recently, Terry Lautenbach, IBM Senior Vice President and member of the IBM Management Committee, visited Endicott to review the progress that we made with VM. As a result of the progress that he's seen, he agreed to speak at a recent VM customer conference. We'd like to share with you right now the comments that he made at that conference.
We have a vision for VM as a key part of the growing client-server environment. VM will continue to be IBM's premier interactive system. We are also developing it as a super LAN, not just for the System 390, but to meet the requirements of a truly integrated enterprise-wide network. To do this, we have made many recent product announcements for enterprise server products, for expanded connectivity, and superior network management. We are building on VM's SAA strengths and on VM's traditional role for guest support. You have asked for VM to be a very open system. We have moved in that direction, and VM will become even more open in the future. IBM will continue to make significant investments in VM so we can continue to deliver the solutions that you want. And you can continue to invest in VM with confidence.
Joyce, I hope you can see why I'm so confident about VM's future.
Yes, I can. Functionality, reliability, and affordability. Those are key concerns of all of our customers. And from the looks of it, you should be congratulated with your success with VM-ESA.
Thanks.
Thank you.
We heard about the Mosaic application today. For more information on Mosaic, call 1-800-442-SAIC. We also heard about performance today. There's a new performance report called the VM-ESA Release 1.1 Performance Report, which you can order. Its order number is GG663236. I'd like to thank you all for joining us today. And I'd like to thank you for watching us. For System 390 Technical Insights, I'm Joyce Tomaselli. See you next time.